Okay, good evening once again. Today we're going to have a new lesson, and it's hypothesis testing. What I did was to purposely provide you the notes, okay, so that you can peruse over this and read through it, and so that our my discussion will be guided by these notes. So I hope you won't mind me uh, just reinforcing what's stated here. For example, what really is hypothesis testing? Okay, it's really a method used when we make inferences. When we say inferences, we're trying to make a judgment. Okay, we're trying to answer a particular, we call it a hypothesis about a population. And we want to conclude if our data is quite similar to the attributes of the population. So the purpose of hypothesis testing is manifold. Marami siyang gamit in whatever fields, in the social sciences, in marketing, in accounting, in business fields, in natural and physical sciences. Importante yung hypothesis testing. Okay? Because what we want to test here is that is what we're observing real, or is it just it just happened by random happening lang yun. So yun ang gusto natin malaman. Totoo ba itong nakikita natin, na-observe natin, or nagkataon lang yan, no? It's just by random chance. So I know in your undergrad or in your other studies, you you had learned about the different steps. No? So we'll just summarize this. So as we said, okay, my statement here is that I have sorry, a hypothesis is an unproven statement. Unproven statement. So this is important. Unproven. Okay. However, this can be either negated or proved. No? So which means that it can be tested. Okay, we want to test if what we're claiming is true or not. Okay, so the steps are we state the hypothesis, the null and the alternative. I'll just breeze through that class because I know you have discussed this in several of your subjects before. So the null hypothesis is the statement that we're trying to disprove. Okay. Now, on the other hand, we have the alternative hypothesis, which is the opposite of your null. Okay. And this is the hypothesis that we're trying to prove and which is not rejected or accepted. Okay. This should be rejected, accepted. Okay. So we don't actually, let me rephrase it. Technically, we don't accept the null hypothesis. The null hypothesis is either we reject or we fail to reject. So these are the fail to reject. These are the conclusions that we derive from the null hypothesis. We do not accept the null hypothesis because we're not really trying to find evidence to prove the null hypothesis. Okay, rather we are trying to find evidence to reject it. Okay, and not to accept it. So after we state the hypothesis, we have to choose a level of significance. Okay, so the level of significance, which is denoted by alpha, in our field, we oftentimes use a level of significance set to 0.05 or 0.01. Okay, but mostly it's 0.05 or 5%. Okay, other fields like medical sciences that really are more, let's say, that would like a stricter uh, assessment of the output would require a higher level of significance. Okay, and then of course, third step, we collect data and perform the statistical test. Okay, so it depends on whatever test you're conducting, whether it's a t-test, simple t-test, an ANOVA, chi-square, regression. Okay, for tonight, most probably we'll reach t-test and ANOVA. For next week, chi-square, and then we're going to start already with the with our discussion on multiple linear regression, okay, which is very important to us. Okay, that's the main model that we're going to look at. Okay, after we collect the data, we calculate the p-value and make a decision and interpret the results. So how do we make a decision? Okay, after we know the level of significance already, let's say it's 5%. So when we have computed the p-value, we compare it with the level of significance. In our case, it's 5%. If the p-value is less than our alpha, so let's say we got 0.03 here, or 3%, and we're comparing it with 0.05. So the relationship is that our p-value is less than 0.05. The inference is that we reject the null hypothesis. Okay? So we reject the null hypothesis. Okay? If on the other hand, the p-value is greater than or equal to 0.05, then we fail to reject the null hypothesis. We do not have sufficient evidence to reject the null hypothesis. Okay, so here is what I was saying a while ago. Accepting so we don't say we fail to reject the null hypothesis, therefore we accept the alternative hypothesis. It is generally incorrect, okay, in hypothesis testing. Okay, because if we say that, then we're actually saying that we're trying to prove the alternative hypothesis. Okay, it's incorrect because in HT, hypothesis testing, it implies that there's enough evidence to support the claim that the observed effect or difference is due to chance. Okay, so I know that's quite a mouthful. What we only need to know is that we don't really need to know the let's say the nitty-gritty rational explanation of rejecting or failing to reject the null hypothesis. What's just important is that the null hypothesis, we either infer to reject it or fail to reject it. So we say, just like as I said a while ago, we reject the HO or fail to reject the null hypothesis. Okay? All right. So let's start with the first one. This is really what we came here to do. Okay. So let's start with t-test, one of the most simple tests. May I have a show of hands, class, if you have done t-test before in your other subjects? Or if you have done it, maybe you have forgotten it. Okay. No? No, Rafi, thank you. Okay. How about the others? Nicola also no? Okay. Thank you. How about the others? Cannot recall. Thank you. No? No? Okay. Thank you. Thank you, everyone, for your honesty. Okay, so we'll proceed here quite cautiously, quite slowly. We don't want, anyway, we have ample time for the other sessions. And as I said, this is more of a build up for us to go into the main model. We will, of course, spend more time there with multiple linear regression because that's really what we're going to use for our paper. Okay? All right. Okay, so let me just read through this. Basically, a t-test, it's one of the most simple tests, and you would like to compare a particular data to a certain, let's say, standard. Usually it's a population, or you may want to compare the averages of a particular data between two groups. So that's a very simple objective of a t-test. You want to compare the means, the average of two groups. You want to know if are they the same or are they different. Okay, there are certain assumptions that, of course, are there are certain assumptions as far as t-test is concerned. And primarily, that assumption is that the data distribution is normally distributed. So there are many tests as far as marketing is concerned, finance is concerned, in marketing, customer behavior is concerned. Okay, and let me show you the formula for a t-test. Okay, if you run this, sometimes my LaTeX. Did I mention to you, class, LaTeX? Have I mentioned this to you? May I know if I mentioned to you before LaTeX here?
No, sir.
No, not yet. I'm sorry. Okay, sorry. Okay, you notice that this equation is written in a certain code. Okay, and this code is called the LaTeX code. You pronounce it as LaTeX and not latex. Okay, so it's very powerful, especially in in creating mathematical expressions, mathematical formulas. So you can see that this expression is actually equal to this one. And we will not go into the details of this, but suffice it to say that this one, it's just fraction. So t is equal to a certain fraction, okay? And you notice that you have here the parentheses, okay? Open and close parentheses, okay? So that will be your numerator. And then you have your other set of the parentheses, okay? Did I miss out on something? Okay. The other parenthesis is this one, and that's your denominator. Okay. So technically, it's just two parts like this. There. Okay. This is your numerator, and this is your denominator. So you can easily see that the formula is nicely written. Okay. You can see here slash bar x. Okay. This represents this one, x bar, and then minus the Greek letter slash mu. This one, and the underscore zero, that's your, oops, sorry, control Z. Underscore zero, that's your subscript there. Okay, and then divided by this one, the other side, you also have another fraction inside. Okay, so you have a frac within a frac. So fraction, okay, S, and then the other part is square root of n. So that's how you write this in. If you're going to write this in Word, it's really very tedious. In LaTeX, it's a bit more. It's easier. Let me share this with you kindly. Okay, I deliberately did not share this. I'll put it in the chat box. Control V. And then please copy it. And then you can see here a more refined way to write the formula. You can see here, nicely written. You have the first one here, right? And then double slash here means go to the next line. So here, text where, and the next line again, okay? Bar x is equal to text sample mean. So we're defining what are the variables, what are they, what do they represent? And so for x bar, that's our sample mean. And then mu sub O, that's your population mean. That's part of your null hypothesis. We're comparing the mean of our data to the sample mean. Okay, then we have S, which is our sample standard deviation, and N, which is our sample size. You don't have to memorize a formula. Okay. Just know that the t-test seeks to determine if the average of a certain data is equal to something. Usually it's equal to a certain standard. So for example, you're comparing the average of the sales of a company with, let's say, the industry standard. So you use the t-test there. Okay, you have one-way t-test, but you also have two sample t-tests. So I don't think I gave this to you, the complete one. So let me give this to you. Control C. And let me put in the chat box, Control V. Okay, so kindly copy this one, and it will give us the two sample t-test. So for two sample t-test, you notice that the formulas are different. You have now x bar 1 and x bar 2. And you have now your S sub 1 and S sub 2. So now you're comparing two sample sizes, two samples. That's why it's called two sample. The other one, the one a while ago, is one sample, okay, one sample t-test, where you have one sample and then you're comparing it to a certain standard. This one, you're comparing two samples, okay, and then you'd like to know if they're equal or not. Okay, so again, don't worry about the formula. You're not going to compute for the t statistics. Okay. So far, are we clear on what's the purpose of the t-test? That's what we want to know. We would like to compare means. Okay. Equal ba yung average nito sa isang standard? Or equal ba yung average nito at saka sa isang ano pa? Sa isang sample? Kunyari, dalawang departments, gusto natin tingnan kung equal yung averages nila on a certain metric, certain KPI. So you can use the t-test for that one. Okay. About the others, thank you, Rafi. Clear ba so far yung purpose ng t-test? And then we'll have an example so that clear sa atin kung ano ba yung, paano ba ginagamit to, paano ini-interpret. Okay. Simple lang naman siya, class, yung t-test. So we'll have an example and then you'll see uh, how R easily generates the result of the t-test. Okay, how about the others? May I have your comments kung clear tayo so far dun sa objective ng isang t-test? Okay, thank you. Okay, good. All right, so let's have an example. Okay, here. Okay, of course, before the example, sabi natin, ano, one sample t-test, you compare a sample mean to a known population mean. Okay, and then ito, two tests, independent t-test to independent because the two samples are independent of each other. Okay, tapos may isa pa, yung paired t-test, we compare measurements before and after. So we'll have three examples dito sa t-test natin. So yung paired t-test, isang test, isang ano din yan, sample. Tapos we'd like to know what is there a difference between the average of this and let's say you kunyari before a company has an intervention, nag-add sila, no? So gusto natin malaman kung yung average sales is the same before and after the ads, no? So yun ang paired t-test. So isang sample lang yan, okay? And then there is a before and after. Okay, so let's take a look at an example. We're going to use a particular data set na it comes with R. So application ito is more on marketing, pricing strategy, customer behavior, and advertising. Okay? I just highlighted there kung ano yung mga uses nitong t-test na to. Okay, for example, sa marketing, sabi natin, testing if stores with higher advertising budgets have significantly higher sales. Okay, so maybe you're comparing two independent samples. Yung isa, mataas yung advertising niya, yung isa, mas mababa lang. So mas mataas ba or wala bang impact ng advertising? Do they have still the same average sales? Okay, you can also use this for pricing strategy. Kunyari, dito sa data natin, we're going to see yung car seats, no? Tapos, yung different positioning ng shelves, okay? Nakaka-affect ba yun sa sales? So, t-test can be done for that. No? Also, customer behavior. Kunyari, yung customers ba sa urban areas versus sa rural areas, magkaiba ba? Okay? Magkaiba ba yung average sales nila? Okay? Also for advertising and maybe for regional analysis. Okay, so let's go here. Okay, so let's start with a one sample t-test. So on one sample t-test natin, we're comparing our data to a known population mean. Let's suppose that we know the population mean. Okay? Ang data natin, we'll see in a while. Let's say the population data is 8, I think this is 8 million. Okay? So we'd like to compare if the mean of our data is equal to 8 million. Okay? Ang alternative hypothesis natin, they're not equal to 8 million. Okay, so let's, this one I didn't give you. I want you to write it. Okay, and perhaps maybe let's use, do you have Pacman already? I'm going to explain first. Pacman P underscore load. And then let's use this ISLR. Okay, could you kindly check, class, if, did we already load Pacman before? Pacman, could you kindly see, please? If you have Pacman, you have this in your packages, please, in your, do you have it? Pacman. Okay, wala. Sige. Some of you have it, some don't. Okay, just to make sure that you know how to load packages in R. So I said before that packages are very important because they contain programs and functions that we can access. These functions are very important for different statistical analysis. So in order to load a package, we use the install.packages. This is the function. And then you identify there the package ISLR, for example. Okay, and once you have installed it, ISLR should appear here in your packages. Okay, for example, ISLR. Okay, so let me just undo detach this. Okay, so if you have loaded, if you have installed ISLR, it will appear here. Okay, but you are not able yet to make use of the functions of ISLR. You will have to load this. You load this by using library, this one. Control X, let me put it here, Control V. So this is the sequence. You install the package first and then use a library. And I think we have discussed before, there are different ways to load, install a particular package. You can use installer packages, or you can make use of the packages window here, okay, and then install. And then type ISLR and then install. I'm not going to do that because it has already been installed here. Or you can go to Tools, Global Options. Okay, I'm sorry, not that one. Tools, and then Install Packages there. The first one that appears. Let me cancel this. Tools, Install Packages there. Same thing as this one. Okay? Or you can make use of another way, this Pacman, but you have to make sure that Pacman is installed. You have to install Pacman first, and then you can make use of the function payload. Okay, payload, and then ISLR. That's what we need. So what will happen here is that R will install the package and then load it at the same time. So one stop deal to class, no? One stop shop, both install and load. However, you have to uh, make sure that the Pacman package is installed, not loaded. You can still run this even if Pacman is not loaded, but it has to be installed. Okay, so just checking, class. Have you loaded ISLR? So this should be checked. Okay, data
Sir,
for sure.
sorry, can I ask for help? Because I don't know if I did it correctly.
Oh wait, that one. Sige. Sorry. Who's that? Angel? Angel ba yan? Hello? Who was asking the question?
Please, sir, Angel po.
Angel, sige. What help do you need, Angel?
Kasi sir, it's nag-red text po sa akin that
Sige.
articles. Can I
Alright.
share po?
Sige,
Just so you
please.
said
I'll stop share and then kindly share, please. Okay. Once again, class, I'd like to encourage you to ask questions. Thank you. Thank you, Angel. Really appreciate that.
I'm not sure if you can see.
Okay.
There po.
All right. Okay. Okay. So, put a space, please, dun
Where
sa
po?
dun sa 106, no?
Here po.
Yeah, sige. Isa pa, please. And then go to 106. Then type yung tatlong tick marks, please. Backticks. Yan. Okay.
Backlit,
Enter mo
sir,
nga.
sorry. Tama po ba?
Backticks. The one on top
This
of
one
tab. Yeah, okay. Enter mo nga siya, please. Enter mo na para may space pa.
Space lang po pala. Okay.
Space lang. Sige. Tapos, install that packages. Bakit kaya walang space dun sa ano mo? No? Hindi,
Here po.
yeah. Wait. Hindi siya. No, you have written it already, di ba? Sa 104, 105.
Yes po.
So, hindi. That's not what we need. Sige, backspace mo. And then, punta ka nga dun sa 106, yung sa last ng backticks.
Dito po.
At dun sa dulo. Enter ka nga, enter. Enter. So, hindi siya nagkakaroon ng differentiation sa color, no? Usually kasi between code chunks dapat nagkakaroon ng difference. Okay, sige, punta muna tayo sa okay. Please run yung 105. Na-run mo na ba siya?
Opo, ito pong red
Okay.
ang lumabas.
Sige, warning R2 is required. Okay. Minsan magaganyang message, ano? But what's important is for you to check packages. Check packages. Kasi nakalagay din successfully unpacked.
Yun nga po, sir.
Oo.
Pero
So,
we're here.
and then you type first dun sa magnifying
Search
glass.
bar po.
Yeah, ISLR. Sige. Spelling, ayan. Okay. So, it's there already, no?
So we're, ayun.
Na,
So okay na po siya.
Yeah, ulitin mo. Packages ulit. Packages.
Packages.
Okay, sige. ISLR. There. Click mo siya. Dun sa box yan. So, that will load now ISLR.
Okay po.
Okay? Sige. So, that's okay, no? Tapos,
Okay
itong
po.
110, 111 mo, kaya siya nag-error kasi wala kang code dyan, eh. No? So, you have to delete that code chunk. Kasi there's
This
nothing
one po.
inside. Yeah, delete that.
Itong
isama mo
110 to
yan.
112 po.
Isama mo lagi yung yung end mark. Yan, isama mo
Ito
siya.
po.
Delete mo siya. Yan. Kasi wala naman siyang code, di ba? Okay,
Sige
there.
po.
Alright?
Okay, thank
Sige,
you po.
good. So, meron ng ISLR, no? Alright. Okay, thank you, Angel. Any
Thank
questions?
you.
Any questions from the others? Share ko ulit yung screen ko. Okay. So we now go to this one. So the ISLR, okay, let's check ISLR here. So this package is data for introduction to statistical learning with applications in R. So it contains functions and also data. So let's click this. Let's see what are the functions. Okay. So ito class, no? Ito yung mga data niya. So we're going to make use of this data. Ito, car seats. If you click this, car seats. Okay. It will give us information about your data. So this is just a simulated data set containing sales of child car seats at 400 different stores. Okay. So these are the variables. It's a data frame, 400 observations, 11 variables. You have sales. This is sales in thousands at different locations. You have competitor price charged by the competitor at each location. You have income. What was the income? What's the income in that community in thousands of dollars? Okay, so your sales is also in thousands of dollars. Advertising is also, it's the budget for the company, also in thousands of dollars. Population size, also in thousands. Price company charges for car seats at each site. And then shelf location, a factor with levels good, bad, good, and medium, indicating the quality of the shelving location for the car seats at each site. And then you have age, the average age of the population, education level at each location, urban, which is a factor with levels no and yes to indicate whether the store is in the location of the store. Is it in an urban location or rural location? And then this one also US, a factor with levels no and yes to indicate whether the store is US based or not. Okay. And here below you can you can find example codes. So this one we're going to use in the future. This is the function for a linear model for linear regression. We'll not go there yet. Okay, so let's go here. We have learned about the data. How do we now access the data from ISLR? The package. We have already loaded the package, so we can get data coming from that. So we can just write data car seats. Okay, so I want you to write this. Also view and also structure of the data. So if okay. Let me remove this first. So if I click this class, data car seats, control enter. What happened, class? Can you tell me what happened to your global environment? May I have your comment, please? When you run data car seats, what happened to your global environment? Okay. Yes. Thank you, Angel. Yeah. There's that word promise. So car seats appeared. How about the others? Did you get this, class? So when you load a particular data, whether you're loading it from another source, you'll get the same. So promise is simply means that your data is available, and you can have it formally loaded by, let's say, this one. Even if I click view here, okay, you notice that it it registers the number of observations and the number of variables. So if I run this, let's run this view. So put your cursor beside it anywhere in front, in the middle, at the end. Okay, and then control enter. Control enter. For Mac, I think it's command enter. Control enter. And it will create a print of your data. So there are 400 entries. It just shows the first 15 and then 11 columns. And as described in our ISLR metadata, This is in millions. Okay, this is how your competitor prices the unit. Okay, we have here income of the community, advertising expense also in thousands, population in thousands also, 276,000. This is the price, okay, how we price the product. This is how the competitor prices the product. Okay, seems that we are lower priced. Okay, and then there's the shelf location. It tells us whether there are three locations here: good, bad, and medium. Tells us whether a particular sale, okay, these are sales, whether that particular object was the car seats, okay, sorry, car seats, child car seats, okay, was in a good or bad or medium location, okay. And this, I think, is the age of the, what's the age? Age is average age of the local population. Okay, so uh, these are different stores, okay. These are different stores, 400 of them. And education also, and urban, or whether it's in US or not. Okay, so I hope our data is clear. Okay, and one thing that we can learn more about the data is get the structure. So this is STR, structure of the car seats, control enter. So what type of data is this? This is a data frame, okay, with 400 observations and 11 variables. Okay, so if you take a look at this, sales, you have numerical variables here, and then shelf location, it's a factor containing 3 levels. When you say levels, these are the different types inside this variable shelf location. Okay, and then you have also urban. So this is just yes or no. And then if it's US, sold in the US, also yes or no. Okay, so this is what you get from the structure. You can also learn more about the data by getting the summary of car seats. So if I type car, capital CAR, okay, there. It gives us a choice whether it's caravan or tab car seats. So what do we get from the summary function in R? Okay, we get this is called your 6-number summaries. Okay, if the data is quantitative, you can have here the minimum and the maximum value. You can have the first quartile. You can have the median is the second quartile, and the third quartile. Okay, so the quartile simply means, for example, first quartile, that's the same as 25th percentile. It means that 25% of your data is below this this amount of sales, 5.39. Okay, for this one, median, which is your 50th percentile, it means that 50% of your data is below 7.49 thousand sales. Third quartile, 9.32. It means that 75% of your data is below 9.32, and 25% are above it. Okay, so if you take a look at your quantitative variables, whether sales, competitor price, etc., you get the 6-number summaries. For the factors, you can only have the count. Okay, shelf location, you either have bad, good, or medium. Then you have the frequency. Okay, the frequencies of the bad, good, and the medium. Same thing for urban. So there are 2 factors here, shelf location and urban. Okay. So I'm right? Shelf location and urban. And the others are quantitative. So the other quantitative variables will have a metric of first quartile, this one, second quartile, which is the median, third quartile is this one, okay? And then you have the average, this is just the average, and then your minimum and maximum values. So just remember that when you say quartile, first quartile, that's the same as 25th percentile. So how do we interpret this? Once again, it means that 25%, okay, 25% of the competitor price is below 115. In this case, third quartile is the same as 75th percentile. So it means that 75% of your data has competitor price below 135. Okay, let me pause for a while and ask for your confirmation if the concept of first quartile, second quartile, third quartile, if that's clear. So it just tells us about the distribution of your data. Is that clear, class? Okay, good. All right. Thank you. All right. Okay, so let's, is there any question here? Okay, sige, Angel, sige, let me stop there again. Let's see what happened to your structure and summary.
Sorry, sir.
Yeah, it's okay. It's okay. Please, please don't be sorry. I really would want you to, if you're encountering problems, please ask questions.
So, sir, I was able to run view, but when I tried to run STR and summary, this is the error that came out.
All right. Could anyone comment? Would you like to help Angel? Let's see. Maybe the others could also suggest something here. Angel, could you move your code higher, please? Scroll up, please. Scroll
Scroll up, sir.
down. Sorry. Up and down. Basta
Ito
upward.
po, sir.
Downward pala, downward.
Downward, ito po.
Yan, okay, yan. Sige. Would you like to comment on Angel's code chunk, please? Would like to comment on that? Anyone? Dom, would you like to comment on Angel's code chunk?
Oh, I think I see it, but I'm not sure.
Sige lang, sige lang. Anyone? Or Rafi, would you like to comment? I'm not sure then. Sige, thank you. All right.
Is it because it doesn't start with this
Not
po?
sure.
Yeah, oo. Your code
okay
chunk
po.
is missing the first, yan, sige, ilagay mo. Yan, always class, the code
Where's
chunk
the
should,
started?
yeah.
Ah,
Or
so
what you can do, naka-Mac ka ba?
no po,
Mac.
Windows po.
Pwede mo i-control Alt I yung shortcut. Pero okay na yan. So now, your code chunk starts with the backticks and then R, and then ends with the backtick. You can run that whole code chunk. You press the green one there. Okay? Yung
This
view
one
dapat
po.
capital, capital V. Okay.
Capital V. Ay. Capital V.
Yan, okay. Sige. You run the whole code chunk. There. Okay?
There.
So,
Okay.
andyan na yung...
So, sir, like probably I can equate it to web coding. It has to always start and end with these po. So that's
yeah.
when the system will
Yes.
recognize the code
Kaya-
chunk.
Correct. So, go down, please, Angel. Okay, go down. Okay, before average sales, put some spaces before average sales. There, sige. And then press Control Alt I at the same time. Control Alt I. There. That's why it's best to use Control Alt I when you're writing code chunks. Kasi kompleto na kagad, no? Okay, so that you
Okay
don't have
po.
to write
Type
the
it
backticks.
manually po.
Oo, pag manual kasi minsan magkakamali pa tayo, no? So
Okay
mas
po.
maganda yung shortcut na Control Alt I. I-take note mo na lang yun para next time.
Okay
Automatic na siya yung Control Alt I. Okay,
Got
thank you. Thank you, Angel.
you po.
Appreciate that. Yeah, you're
Thank you.
opening the room for everyone to learn, no? So this is good. Okay, thank you so much. Okay, I hope you don't, everyone, please do not be ashamed of asking questions. Okay, so now let me first start with this. Can we get, I'm not sure if we discussed this before, but can we get the average of sales? Can you do that? Where is sales? Sales is part of our car seats data here, right? Can you get the average of sales? So please run this mean, because that's mean is the average, right? Mean of sales. And tell me what happens when you do that. Would you please write in the comment box what you got? Okay, errors, object sales not found. How about the others? Thank you, Hannah. Okay, Dom, thank you also. Object sales not found. For the others, were you able to get the average of sales? All right, Nico, thank you. Let's wait for the others. Not found also. Okay, not found. Jet, not found. Okay. All right, Raf, thank you. Okay, what could be the reason for this class? If you take a look at your environment here below, here, the environment will tell you what are the objects that are recognized as. There's only one object that we have loaded so far, car seats. And sales is not one of them. Okay? Sales is not one of them. That's why when we ask R to get the mean of sales, it says object not found because you haven't loaded the sales object here. However, class, if you take a look at this, let's once again get the structure of car seats here. Control Enter. Just this structure. Okay, you can see now that there's a dollar here. Okay, so this is car seats and then dollar sales. So what does this mean? You can only access sales by going through car seats because the object that's being recognized is car seats and not sales. But can I get through sales? Yes, you can. How do you do that? The use of the dollar sign here. Okay, so let me illustrate that. Okay, so here first, I'm getting the mean. So I will have to use car seats. And if you type car, it will automatically tell you what are the objects that start with car available in R. So here, car seats, tab, okay. And then if you press dollar, what happens? If you press dollar, what appears now will be all the objects, all the variables that are inside car seats. So you have sales, competitor price, etc. Okay, so I can now access sales. So you can click arrow down, arrow up, and go to the item that you want loaded, and that's sales. And then you don't have to type sales. You just press tab there. Okay, I want you to practice that, please, so that next time, if you're getting, say, the standard deviation, okay, so let's say you type first the object, car seats, and you have it there already. Tab, arrow down, tab, and then dollar. Dollar will now, okay, there's a dollar. Okay, let me rewrite. Sometimes it's not cooperating. Car seats, tab, and then dollar. Okay, there. After typing dollar, I now have access to what's inside car seats, whether it's sales, income, etc. Okay. So for example, if I get the average of urban, tab, control enter. Okay, of course, it will not it will not have any answer because urban is a character variable. Okay, it's either yes or no. So you can't get the average of a character variable. So let me replace this by sales. Okay, let me write dollar again. Very convenient so that I don't have to write sales. Tab, Control Enter. There you go. And we're able to get the average of dollar of car sales, which is around 7.5. Okay, so let me pause for a while and ask you if you were able to get that that value. Okay, good. Thank you. Thank you. Okay, good. All right. So next time, class, when you're working with objects in R and you want to access a particular variable, you have to go to the object itself. Now, is it possible, another question, is it possible? So I'm going to insert a code chunk here, Control Alt I. In Mac, I think it's Command Option I. Okay, shortcut to get the create a code chunk. Okay, let's see. Mean, and then what are the other variables here? Let's say stand mean of advertising. Let's do that. Okay, mean of advertising. Of course, we know that we can't run this. Okay, as is, we cannot run that. But is there a way, a technique for us to be able to access this and get its mean? There is. Okay, by defining what from where these objects are that you're going to access. For example, let's say I'm also getting the standard deviation of what other variables here, standard deviation of, let's say, population. Okay, standard deviation of population. Okay, so if you run this now, it will generate an error term because advertising and population are not recognized by sales. So what do we do? There's a technique and it's called attach. Okay, so we're going to use the attach function, car seats, tab down, tab. Okay, the attach function will allow us, okay, I will recognize that after this, after attaching car seats, all the other objects here will be coming from car seats. Okay, so that will simplify also how you write your code because you don't have to write car seats here, population here, okay? But just be careful because you might have several objects here and then it might cause a conflict when you use another object. So after you attach, it is suggested that you detach if you're going to use another object so that it will not cause confusion. Okay, so let's run this first, car seats, there. And then I get the mean of advertising. Okay, so it's 6.63,000. And I get the standard deviation of the population. It's 147.3764. Okay, so without using car seats, we were able to get the mean and the population. Okay, again, let me pause for a while and see if you're able to follow. Okay, good. Thank you. Thank you. Yeah, good. All right, good. Okay. All good. Thank you. Salamat, ha? Salamat for your cooperation. Okay, and then good advice is to, after you have used that, detach, okay, car seats. In case you're going to use other objects, it would be good to detach from car seats so that it will not cause confusion. Enter. And then if once again, if I use mean advertising, it will not recognize the object again because I have detached car seats from that. Okay. All right. So these are some let's say simple tips and tricks that we can use in R. Okay, let's now go to our t-test. Okay, so this is our remember we have three types, right? Yes. So let's in order for us to situate ourselves again, okay, we have this, right? The three types that we're going to use is a one sample t-test, the independent, and the paired t-test. So let's start with the one sample here. So this is your one sample. And let's copy again here. Let's copy this again here so that we don't lose Control C on our objective. I'm going to copy this here below. Okay, one sample t-test. We would like to compare a sample mean to a known population mean. So let's suppose that in this industry that sells car seats, the population mean is the sales is at eight what sales? 8,000? Yeah, I think it's in thousands. Liit na, sorry. Anyway, this is just a simulated data, just for purposes of discussion. At better kung millions ton, 8,000. Okay, so let's suppose that we know the population mean. So it could be that there's an industry association and all of them contribute data. They contribute their sales data, and the industry association comes up with an average. Okay, let's say that the average is 8, and we'd like to see if the our company's car seats are at par with the industry average. Okay, so what are we doing? We're comparing the mean, the average sales of our company to that of the population. So that's what's happening here. And that's called a one sample t-test. So we know the population mean is 8,000. Okay. And we also have our mean actually, right? So here, our mean is 7.49. So the question is this 7.49 actually just about equal to the population mean? Okay, so that's what we're going to do. That's what we're going to test. So again, very simple in R. The function is, okay, I didn't give this to you, so please write this down. T dot test. Okay, why don't we do this first so that, okay, if sometimes if you're using a certain function for the first time, it would be good to go to the console and then write the test, write the function t dot test here. Okay, so control enter, and usually R will give us a help. Okay, from where that comes from. Sometimes there are many, so we just have to check. Okay. Here there are many. The problem sometimes is that there are so many, you don't know now which. Okay, where is that t dot test? It's sometimes because of here as students t test. This might be it, or usually it's from the stats package. Let's see, stats package. No, it's not. There's also this one, R statistics, T underscore test. So there are many similar tests on that. Okay, so looking for that T dot test. So this is one of the disadvantage here, class. Here, class. But here, okay, it's from the stats package. I guess it right. Stats T dot test. So if we click this, it will give us some information about the test. Okay. So if you take a look at the full scope of the test, but there are many parameters. Okay. So you have first your data, and then your null alternative, whether it's two-sided, and then your mean here, what's the average, and then is it paired? Okay, and then about the confidence level. So you can see here that there are many parameters that you can insert, but the basic one is just, okay, it's just identify, just like what we did. And there are some examples here that you can use here. Okay. All right. So if you need more information plus of a particular function, the help function of R is really very comprehensive. Okay. So much so that it becomes difficult to find what you're really interested in because of so many similar, okay, some similar functions. Okay. So let's now go here. We're just using a simple one here. We identify the data and then, okay, it's car seats and then sales. And then we would like to compare it with the mean, population mean, which is 8. Okay. All right. So let's run this. Okay. So we have some outputs here. So data is car. Oh, wait, let me pause for a while and ask you, are you able to follow class and run that one sample t-test? Are we all good? Okay, good. Thank you, Hannah. Raf, thank you. Okay, the formula again. Okay, sure. Okay, so let me show the formula again, this one. Okay, I think I should go back to the bigger appearance. Okay, the 24 will be okay again. Okay. All right. So this is our T-dot test. The data is car seats, dollar sales. And then we compare it with mu, which is the average population data. Okay. Okay. So we have here, class, the output data is car seats, dollar sales. Then we have the T value, 3.567. So how was this computed? This was computed, class, using the formula that we showed a while ago. So let me just go back to that. You recall this one, class? Here. The T-stat was computed by getting the average of your sample, which was the 7.4, and then subtracting the average 8 divided by S. S is the sample standard deviation. You get the standard deviation, and then you get the square root of n. So just for purposes of example, okay. So let's just as a practice in R. Okay, so you have here t test, right? Alt minus. Okay, so what are we doing here? Have I, class, discussed the assignment operator with you? Could you please, I'm sorry, sometimes I get confused already with the, if I, because of the other subjects that I'm handling. May I know, class, if I discussed the assignment operator, this one? Have I? Because this is very important. Yes or no, please? For example, this one, I'm creating this object, T underscore test, and then I'm using this one. Have I, class? Yes or no? I think yes. Okay, yes. All right, good. So, so here I'm creating this object, T test, and it's, you can name it any way you want. And the formula is, okay, let's copy the formula here, okay, so that we're guided. This one, Okay, maybe just this one class. Control C. And then $, and another $, and then Control V. I just copied the formula class, and then this is what you get. Okay, so we're going to use this. Maybe let's just Control Alt I. Okay, sorry class. Let's just compute it here. Okay, so let's create this object called let's just call it T. Okay, maybe T test. Okay, Alt minus. Okay, so what's this class? There's a practice on how we use formulas in R. This is your average class. X bar is your average sales, right? So we can make use of the mean. Mean of, again, car seats, and then dollar sales. Okay, so that's the mean of car sales, right? Minus, you're given the population. Okay, maybe if I can, let's create here pop mean alt minus 8. So I'm creating a variable called pop mean, population mean, so that I'll be using that here, pop underscore mean. Okay? So that the formula will become, it will be better because it refers to a variable. So I created population mean, which is equal to 8. So I'm now writing this. The average we get by mean of the car seats of sales, and then minus the population mean. And then I'll have to put this under in quotation, in parentheses. Okay, this will be our numerator. And then we're going to divide it by, so divide everything by, let's just take a look at this. Okay, let's put everything in parentheses. And then S here is a standard deviation. Standard deviation of your, again, car seats, dollar, standard deviation of your sales. Okay, there you go, class. Okay, and then divide it by the square root of n. Okay, so what's the square root of n? Okay, let's put that here, class. Okay, I'm creating this object called n, alt minus. And n is the length, okay, or n row, number of rows of your car seats. Car seats. How many rows does the object car seats have? If I run this first, okay, n is 400, right? The L here stands for integer. Okay, 400L does not mean liters. It means it's an integer. Okay, divided by n. All right, so, divided by, I have to put the square root, SQRT, of n. And I have to close this one. Okay, so maybe I'll put this here. Okay. All right. So let me explain what I did just now. Okay, this is the formula to get the T stat. Okay, although we're not going to really, I'm not going to ask you, for example, in your paper, of course, you're not going to show this computation, but this is just for the purpose of really enhancing our skills in R. So n row the n row function will give us the number of rows of car seats. And we know it's 400. So that's your n here becomes 400. Okay, your population mean is given at 8. So this is that figure. And then X bar is the mean of your car sales. Okay, so that's mean car seats sales minus the population mean minus this one. Put it in parentheses to close it. Then divided by, okay, standard deviation of car seats sales divided by the square root of n. Then close it also. So if I run this, okay, and then let's print this one, T underscore test to print it. So the answer is negative 3.57. And let's compare that with the value here. Okay. Where's that? Here class. 3.567, exactly the same. 3.567 to the nearest 3 decimal places. Okay. All right. So let me pause for a while. I'm sorry, I might be going too fast. I just wanted to validate whether that really is a t-test. Okay. So if you're copying the formula and if you're done, kindly please chat yes for me to be informed if you're okay or if you have any questions. What do we do if we found object is not found? Sige, okay lang. Okay, Angel, kindly once again share your screen. Stop share ako.
Hold on lang, sir. I'll redial because I'm using or on another laptop. Sorry.
Okay, okay. Sige, sige. Okay,
Let me just redial po.
all right, sige. It's okay.
Ah,
Okay, Angel, we appreciate your questions, okay? So please don't stop asking questions because I'm sure everybody will learn from this exercise.
sorry, hold on lang po. Just trying to
Sige, it's
redial
okay.
my other laptop.
Okay, Jet naman, okay. May question din si Jet dito. Si Jet. So while Angel is loading, Jet, hindi ko ma-print yung ano. Ayan, to. Wait, huh? So, Enroll car seats, population mean. Okay. Yeah, this is correct. Tama. 3.5, negative 3.567. Renound off lang yan. So, thank you, Jet. Tama yung code mo. Okay. So, let me see. How about Angel's code? T-test not found. Okay. T-test not found. Let's see. Okay. Enroll. Population mean. T-test. Okay. May kulang ng, ayan, may kulang na parenthesis sa dulo. Sige, lagay mo, sige. Run that now, Angel. Oh, wait. Sorry. Sobra-sobra na. Mean population nakasarado na, no? Tapos standard deviation divided by square root of n. Yeah, tama. Tama na. May open and close parenthesis ka na sa dulo.
Opo.
So kindly run that again, Angel. Population mean not found. Okay? So we created that. Ano yung rinaran mo, Angel? What were you running? Were
T-test
you,
po.
sorry?
T-test po.
You
This one.
have to run all the codes kasi dapat ma-run din yung population mean. So dapat ang i-click mo yung green nag-arrow, yung green. Kikita mo yung green na arrow sa taas. There. Yan i-click mo para lahat ma-run, no? Run current chunk. Sige,
Okay po.
Nag-run na siya sa ilalim.
Here na po sa baba.
Yan. And
Okay.
after yung t-test, mag-enter ka dyan. Yan. Tapos above, write the underscore test para ma-print din niya yung t-test. Okay, run everything again. Yung green yan. Okay, so yan, print na niya. Negative 3.567. Okay, good.
Okay po.
All right, thank you. Okay, good. Sige. So let me continue. And, all right. So, okay, so let's now go to the interpretation. Okay. So you have a t-test, negative 3.567. Okay, we will interpret the t-test in the light of the p-value. Okay, this one. Okay, the negative there indicates that your sample mean is below the population mean. The population mean is 8. So it's telling you that your sample mean is negative. It means it's below 8, the population mean. You have 1 degree of freedom. Okay, where did this come from? You have your n is 400 minus 1, which is for the one sample that we're using. So that's why your degree of freedom is 399. And then your p-value is 0.00405. So let's interpret this. Okay, we have to go back to our null hypothesis. The null hypothesis is that the true mean of our sales data from car seats is equal to 8. Okay, so remember, this is a one sample test, one sample t-test. We are comparing the sample to a population. Okay, and as I said, the context here is we know the population mean. Okay, in an industry, if you're comparing the company value with an industry, especially, as I said, especially in the US, there are industry associations, and they tend to come up with average values of different metrics. So you can use your metric and compare it with the industry, and test whether your metric is equal, statistically the same as the population metric. So in this case, okay, the principle in inference in creating an inference in stat is that when the p value, when the p is low, the null must go. Okay, so I find this easy to understand. Okay, what do we mean by this? So we have the p-value here. The p-value is 0.000405, right? It's very low compared to what's low here? The alpha. Our level of significance is 0.05. Okay, so alpha is equal to 0.05. Okay, so we need to compare, which is the level of significance, We are comparing the the p-value, which is, okay, our p-value is, let's write our p-value here. P-value is equal to, okay, I think I should write this here. Control X, because the result is below here. Okay, p-value is 0.00. Okay, here, 0.00405. Control C. Control V. Okay, so let's apply this principle, class, when you when you make an inference. So we have this. When the p is low, our p is 0.000405. Low means in reference to your alpha, your level of significance. So your p is lower than your 0.05. Therefore, what would be our conclusion? The null must go. So what's the null? The null is that the sample mean, okay, the sample mean is equal to the population mean. It's equal to 8. So the null must go, class, means we're going to reject this. Okay, we reject the null hypothesis that the sample mean is the same as 8, is equal to 8, which is the population mean. So that's our inference there. We have statistical reason to believe that the sample mean is not equal to 8. All right. In fact, it's lower than 8 because of the negative t stat here. Okay, so you have you have your null hypothesis and you have your alternative hypothesis. Okay, the alternative hypothesis is the true mean is not equal to 8. And we're given even a 95% confidence interval. So what does this tell us? This tells us that the real mean of our sample lies between 721 and 7.7. Okay? In fact, the computed sample mean is 7.496. But the real mean is, we have 95% confidence that the real mean of our sample lies between 7.22 and 7.77. So, in this interval, you cannot find 8, right? Kasi tinetest natin kung equal to 8 siya. Okay? It's okay. It's okay, Ralph. It's okay. So, so this is what that means, class. So what's the inference here? What's our answer to that question? Okay, the question is the sample mean, the mean of our company, the sales, is it equal to the population value? And the answer is no. Okay, we reject the null hypothesis that the true mean of our car sales is equal to 8. Okay, so it's a pretty straightforward analysis. And here, class, let's just go over this. I already wrote this so that you will you'll be able to it's already available to you. The T stat is negative 3.567. It measures how much the sample mean, which is 7.496, deviates from the hypothesized mean, which is 8, relative to the sample variability. Okay, how much it differs. The negative value means that the sample mean is less than the hypothesis mean. Okay, if this was positive, then that means that the sample mean would be greater than 8. Then the degree of freedom I mentioned to you a while ago, 399, which corresponds to the degree of data points minus 1. So you have 400 minus 1. Okay, 400 minus 1 because you're computing for one parameter, which is that the t-test. Okay, the p-value is this amount, which represents the probability of observing a test statistic. Okay, sometimes the definition of the p-value is, sometimes it's complicated by statisticians. Okay, it says here a test statistic at least as extreme as the one calculated, assuming the null hypothesis is true. Okay, what's important for us is to compare your t-stat, your p-value, and with the level of significance. A value of 0.004 is very small, indicating that there is a strong evidence against the null hypothesis. So we're rejecting the null hypothesis. Since the p-value is much smaller than our level of significance, which is 0.05, we reject the null hypothesis. And I also mentioned about the confidence interval. The 95% confidence interval is between this one and this one. So we are 95% confident that the true population mean, okay, is between 7.21, okay, and 7.739. Okay, since the hypothesized mean of 8 is not within this confidence interval, this further supports rejecting the null hypothesis. Okay, and in fact, we also have the sample estimate of the mean of X. Okay, it's 7.496, which suggests that based on the sample data, the average sales is lower than the hypothesized mean of 8. So in concluding, class, so the evidence show that the population mean, okay, we're rejecting the null hypothesis that the true mean of car seats sales is 8. Okay, the true mean of car seat sales is likely different from 8. And based on the confidence interval, it appears to be between 7.22 and 7.77. Okay, so let me pause a bit there. Sorry. I know I must have chewed a mouthful. Okay, and let me pause for a while and Ask if so far it's okay with you. May question dito si Dom. Dom, paki-share yung question mo sa ano? Sa lahat, please. Is one-tailed, two-tailed variations of one sample t-test possible? There is no distinction required. Okay, is one-tailed, two-tailed variations of one sample t-test? Kasi, Dom, when you say one sample t-test, you're only dealing with one sample. One-tailed, two-tailed. Okay. Okay. If you take a look at, thank you. Sorry, I misread your question. I was thinking of two sample. No? So, ang question ni Dom, one-tailed or two-tailed? What's the difference, class, between one-tailed and two-tailed? Okay. So, let's go back here. Meron kasing, yung dito, class, yung kanina, no? Yung t-test natin. Okay, magagamit natin to. Okay. So here, makikita natin yung alternative, no? Two-sided, less, greater. Okay. All right. So pwede, no? Kasi remember, yung t-test natin, ang ginamit lang natin yung simple. Okay. So yung ginamit natin is, okay, ano siya? Dom, two-sided, less or greater? Two-sided or one-sided?
Two-sided po ba, sir? Kasi
Two-sided,
not equal
correct.
po yung alternative.
Oo, kasi tama, no? Ang null natin is equal to, ang alternative natin is not equal to. Okay? So, we can, okay? We can specify the mean, tapos pwede natin sabihin alternative, either less or greater. So, for example, specify the mean is equal to 8, di ba? Tapos, we put in here, okay, ito pala, ito yung mean natin, ano? Mu is equal to 8, for example, and then we cite the alternative. So, what happened was, yung default natin kasi two-sided, no? So, hindi natin linagay ito. Okay? Pero, we could have we could have specified, no? Kung less siya or greater siya. Okay? So, for example, if we use less than, what we're hypothesizing is that the mean is less than 8 or greater than, okay? So, greater than 8. Okay, so I leave you, Dom, first to try this, no? Ang gagawin natin, kasi magkakaroon tayo ng example na ganito. But I'll just discuss that as we go along. So hindi ko muna i-discuss to Dom, ha? Pero thank you, Dom, for that question. The question of Dom is about one-sided and two-sided test. I'll discuss this when I go to one-sided and two-sided. Okay lang ba, Dom? Okay. Yeah, okay, thank you. Good. But you can. The quick answer is pwede siya. And will it yield the same result? We don't know. We have to test, no? We have to generate the test. So depende kasi yan kung depende yan sa tinetest natin. Okay? Ang gusto ba natin i-test na kung greater than siya? Greater than or equal to 8? Okay? So we want to test if the okay. But I promise to discuss that. No? I don't want to discuss that now kasi it might create confusion dun sa alternative natin na less than or greater than. Okay. Sige, so for now, let's go to the next one. Okay, would you want to have a break now, class, or we continue? What's the pleasure of the class? Kasi naka 2 hours na tayo. And I know that stat is not an easy thing to discuss. Would you want to have a quick break time, maybe? Sige. Okay, so let's have a 15-minute break. It's almost 8, so let's come back at 8:15 and then we continue our lesson. Okay? All right. Sige, pause recording. So let's now go to the next type of t-test. So going back to the question of Dom a while ago, as to the two-tailed, one-tailed and two-tailed test, we'll have an example of that. Okay. Tingnan natin kung maabutan natin yung example na yun ngayon, no? Okay, so the next one that we're going to do is independent two-sample t-test. So the assumption here is that you have two groups, independent groups, and you'd like to compare the means, the averages of the two independent groups. If you take a look at our car seats, we can use this. Okay, so we'd like to compare the average sales of urban and non-urban or rural. We'd like to see if the sales in urban areas, the urban region, is the same as the sales in the rural region. So our null hypothesis is that the average sales in urban and rural stores are the same. So no difference.
Sir,
So
sir,
yes.
sorry, are you sharing screen?
Am I not? Sorry.
Yeah.
Thank you. Yeah, I'm not sorry. Okay, thank you. Okay. All right, so we're here now at independent two-sample t-test. So the name itself is very self-explanatory. You have two independent samples. Okay, they're totally different, mutually exclusive. No? For example, urban and rural. You cannot be both at the same time. The sales could not have come from urban and rural store at the same time. So we're going to test whether the average sales from our data in the urban areas and rural stores are the same. The alternative hypothesis is that they are different. Okay, so let's first see the frequency. Let's do table. Okay. By the way, if you want, did we discuss if you want the proportion of this? Okay, I don't think so. So maybe let's see per, I don't know, percentage of let's see, percentage urban, maybe PCT urban. Okay, so alt minus. Okay, I'm going to create a table. Car seats, should have copied it. Car seats dollar. Then you have your urban. Okay. So first we create an object called PCT urban, percentage urban. Control enter. Okay. If I print this PCT underscore urban, percentage urban, okay, we get exactly the same as this one. However, I created this so that we can now do this. Okay, what I'm going to, okay, let me, should I use another one? Okay, let me see if I can create this proportion that table. Then I'm going to use PCT urban. Okay, control enter. All right, there. So what I did was just to give a proportion in terms of percent. So if you need that, okay, instead of the count, here you have both. You have the count and the percentage. What you do is to use also the table function, but give it a name, the result, give it a name, and then use the proportion that table function and load it to the proportion that table function. Okay. All right, you got this, class? Okay, in case you want the proportion instead of the count. Okay, once again, may I request your feedback if if you were able to follow? Okay, good. Thank you. All right. Okay. Okay, good. Thank you. Okay, so let's continue. This one I did not, I only gave you the print results, but this one I did not. So let's take a look at this. What's happening here? I want you to write this so that you experience the writing of the code for this one. We're getting the average sales of urban, and we're just getting the mean of car seats sales. However, we want only the urban, okay? From the sales data, we only want urban. So the bracket here stands for, let me put this here, okay? All right, mean of the car seats data, dollar sales, and then we are subsetting it. Car seats, dollar urban, and it's equal to yes. Okay, you have to use two equal signs. Okay, equal to yes, and then close it, so that here you'll get the average sales of for urban, and then this one also, you'll get the average sales for not urban or rural. Okay, I'll give you a few minutes, few seconds to write the code. I want you to be the one to write that on your own. And then I think I gave this to you. This is just to print. So the average, put it in quotations, the average sales for urban stores, then it will print this one, average sales of urban, which is this one. Okay. Number. So let me print this now, and you should be able to get this. Average sales for urban stores, 7.4. Average sales for rural stores, 7.56. So that's how you get the let's say you're getting the average from a particular variable in a data set that contains several levels. And the chat, yes, please, if you're done. Good, thank you. Okay, so let's give a few more seconds to your classmates. Okay, thank you. All right, so you can see here that the average sales for urban is 7.46. For rural, it's 7.56. So more say average sales for the rural area. So we'd like to test whether these values are practically the same, statistically the same. The null hypothesis is that the average sales in urban and rural are the same. So if we get, it's just like getting the difference. For example, the mean, the average of sales for urban minus the average sales, or not mu, sorry, x urban sales minus x rural sales is equal to 0. Okay, there's no difference. So this is what we're testing. The alternative, of course, is they're not equal to 0. Okay. No difference versus they are different. Let me clear this. Okay, so what's the function class? Very easy again. T-test again, but this time here, sales tilde urban. Okay, sales tilde urban. So this is similar to the one that's used in regression model. Okay, so if you run this, again, t-test, t.test, sales tilde urban, data is equal to car seats. Okay, let's run this. Okay. So we have a two sample t-test using Welch. Data is equal to sales by urban. So this is sales tilde urban. And then you have the t-stat 0.309309, degree of freedom 221, p-value is 0.7576. Okay. We're told here that the alternative hypothesis is that the true difference in means between the group no and yes, or rural or urban, it's not equal to 0. So which means that they're different. All right. So what's our conclusion, class, based on the p-value? If the null hypothesis is saying that the null hypothesis is that the means are the same. So x, the average urban, is equal to the average sales of rural. They're the same. Okay, which can be stated as, if we transpose this to the other side, this becomes urban minus average rural is equal to 0. Okay, that's why this and this are equivalent. So we're just saying that equal yung means nila. The average sales in both areas, locations are the same. The p-value is 0.7576. So as we stated a while ago, when the p is low, the null must go. Okay. So here, the p is 0.7576. Therefore, our inference, our conclusion is that we fail to reject the null hypothesis. We fail to reject the null hypothesis that the means, the average sales in urban and rural are the same. We fail to reject that. So there's strong reason to believe that the average sales are for both areas, urban and rural, are the same. Okay, the p-value is 7576. Okay, in fact, if you take a look at the 95% confidence interval, based on this, the difference will lie between negative 0.512 and it will be and 0.770. So if we plot this, okay, if we plot this, this is negative 0.5. This is 0.7. And in this possible range of values, there's a probability that it will be 0. Okay. We're 95% confident that the values, the difference here, the difference in the averages of the sales range between negative 0.51 and 0.71. In this 95 confidence interval, we're 95% confident that it's between these two values. The zero value lies here. Okay, 0 is between these two values. So there's a possibility that this difference is equal to 0. Okay, so that's the reason why we are failing to reject the null hypothesis, that the difference is equal to 0, because 0 lies between these two values, and it's possible that the difference would be 0. Okay, in fact, this is what we got a while ago. This is the mean for no, which is rural, and mean for yes, which is urban. Okay, so this is an example of two sample. Okay, we're comparing the means of your urban and rural. They're independent samples, and this is what we get if we use. This is the syntax for that: sales tilde urban, and it's quite different from your t-test here, which we use t dot test also. Okay, but the syntax is, okay, the data and then the specific variable, and then we have to identify the population mean, okay, the mu. All right. So taking a look at the results of this independent t-test, once again, I provided you with the summary of the analysis. Okay. Test summary: the t-test compares sales between two groups: urban, which is yes here in car seats, okay, here, and rural, which is no. Okay, the t-stat is 0.3031. This value represents the difference between the group means relative to the variation within each group. A value which is close to 0 suggests that the means of the two groups are very similar. Okay, so this is the difference between the group means, okay, relative to the variation, which is relatively small. So if it's very close to 0, so that means that the difference between them is relatively very small, which means that the two groups are practically the same. And then we have the degrees of freedom. It's computed differently from this one, okay? And what's important for us is the p-value, which is greater than 0.05, which tells us that we have to reject the null hypothesis, okay? That we fail to reject, I'm sorry. We fail to reject the null hypothesis that their means are the same, that their means are equal. Okay? There is no significant difference in sales between urban and rural, as the p-value is greater than 0.05. Confidence interval, as I mentioned a while ago, from negative 0.5 to 0.7. 0 lies between this one. So which means that there's a possibility that this difference is equal to 0. And if the difference is equal to 0, then that means, okay, because if you subtract the rural average minus the mean, the urban average, and if they're equal to 0, then that means there's no difference because pareho lang sila. So ang nagiging difference is 0. Okay, supporting the conclusion that the means may not be significantly different. Okay. Okay. So based on the t-test, we fail to reject the null hypothesis. No statistically significant difference in sales between urban and rural. Okay. And the last 4 t-test is the paired t-test. So it compares. You have one sample, okay, before an intervention, and what happens to that sample after the intervention. So for our data, we'll just make certain assumptions. Okay, we're going to make certain assumptions that the mean sales before and after increasing advertising spend are the same. We will assume, okay, so there's advertising. Okay, we will assume that, okay, the data from 1 to 100 is before sales, and then data from 100 to 200 is after sales, after the advertisement, the sales before ads and the sales after ads. So this is an assumption we'll make. Okay, of course, in the real world, you have data, you have separate data for before advertisement and after advertisement. So because of the limits of our data, okay, from 1 to 100 of sales, we will assume that this is before the advertisement. And then from 100 to 200, it means that it's after the sales after the advertisement. Okay, before sales, before advertisement sales. Okay, so we get car seats sales 1 to 100. So we're creating this object. It will contain 100 observations, and it's from the car seats data, the sales data, the first 100 observations. This one is for the next 100, from 100 to 200. Okay, so if I run this, so kindly follow along, please. And this is an object that we created. Okay, so we now have before sales. So if we view that, view before sales, okay. Okay, so it's a vector. It contains 100 observations. So let's get let's print, or let's just before underscore sales. Let's just print this. Okay, so this is your data. 100 observations. So this is our data. And then after sales, so this will be matched, okay? 100 to 101 to 200. Okay, so I can print here after sales. Okay, so this is the last last 100. Okay, is there any question about the data? We were just assuming for purposes of discussion that the first 100 observations were a record of sales before the advertisement, and this one after the advertisement. Okay, so this is a paired test. Okay, so we have one sample data, and then it's split into before sales and after sales. Okay, so we're using again p-test, and the syntax is before sales and then after sales. And then we have to define that it's paired. Paired is equal to true. So you can see the difference between a one sample t-test, an independent two sample t-test, and a paired t-test. Okay. So I'll wait you class to run. I'll wait for you to run the code, and then if you're able to run it, please chat yes. Okay, thank you, Angel. Let's wait for the others. Okay, good. All right. Good. Okay, so let's run this now. I'll run this now. Okay. You have paired t-test, data before sales and after sales. You have the t-value here, degree of freedom, and the p-value. And again, what's our null hypothesis here? The mean sales before and after increasing advertising spend are the same. So just like the two sample, okay, we were testing urban and rural. The null there was they're the same. Here also, before and after, they're the same. Okay, and again, let's quickly go to the p-value. The p-value is 0.3207. So this tells us that, okay, we fail to reject the null hypothesis that the average sales before and after advertising are the same. So we fail to reject that. So the implication of this is, okay, if you're marketing, the implication is, okay, what was the advertising for? If there's no difference between the average sales before the advertising and after the advertising, then of course, we can come up with certain, let's say, decision making about this for the company, for the marketing department. Kasi kung hindi din nagbago yung sales before the intervention and after the intervention, then something must be wrong. Okay, so that's now that can now lead the company to assess kung okay ba yung advertising nila or hindi. Okay, so here once again, okay, the difference between the before sales and after sales. Okay, so the null hypothesis there, as we said, they're equal, or it can be written as the before sales minus the after sales is equal to 0. And the difference is between negative 0.4 and 1.24. Okay, so the difference lies, we're 95% sure that the difference between the before and after could be from negative 0.41 to 1.2. And we know that 0 lies between them. Okay, so which means that the difference, there's a possibility that the difference is 0. Okay, when you subtract before and after, the difference is 0. Okay, in fact, the mean difference is 0.4169. Okay. All right. Any questions about this? Clear ba tayo so far, class? All right. Good. Good. Thank you. Okay. Now, since we're going to have a class on Saturday class, again, the attendance is not required anyway. I just check the attendance, but I don't really give it much value. Your master students, you are a responsible class also for your learning. Okay. And the next one is ANOVA. And mabibitin tayo class kung sisimulan natin to. So let's just discuss this ANOVA and chi-square next meeting. So that next Saturday, next Saturday, not this coming Saturday, because I won't be able to meet you on Thursday. That will now pave the way for us to go into multiple linear regression. Okay? All right. So mahaba-haba din kasi to. So I don't want to kasi ang ANOVA may post hoc pa eh. Okay, magtutuki tayo, magpo-post hoc tayo. So I don't want to start. But may I request you to please go over the notes, no? What's ANOVA for? At least yung una siguro. I'm sure you can okay. For the first ones, kasi hindi ko binigay, ano? Okay, let me give class. Okay, let me see. Kindly copy this. Kahit ito muna. No? Control C. Let me see if I can copy this. Control V. Ayan, pwede. Okay, at least for the first three, Yung mga blanks, ano nyo, you can copy it and post the, and then that's the first ANOVA. So the explanation is here. And then the post hoc. Okay, sige, ibigay ko rin yung post hoc ng una. Okay, this one, so that you can have a head start. Okay. If you can, please, Control C, and then I'll put it in the chat box again, Control V. All right, good. So I gave you the code already. So I suggest that you take a look at this. Same data naman to, no? Same data, and the notes are there, and even the explanation of the results are there. So if you run the code class, especially this one, AOV, that's the ANOVA, okay, analysis of variance, and then get the result, the explanation are here. Okay, so again, class, just by way of introduction, for t-test, you're comparing between one sample, right? You're comparing it with the population. Independent two sample with among two. For paired, you're comparing one data set and then between levels of that data set. For ANOVA, you're comparing means across more than two groups. So if there are more than two groups, you can't use t-test for that. You'll have to use analysis of variance. Okay, so same thing, it determines whether at least one group mean is significantly different. So same thing, we're testing the means, but this time there are more than two. Okay, so we have one-way ANOVA. Okay, this is the first one that we're going to see. Compares the means across multiple independent groups. So for example, the average sales are the same across different shelving locations. So in our data, you have shelf location. You have bad location, good location, and medium location. So the question is, are the average sales for the bad, for the good, and the medium, are they the same? So you can't use t-test there because there are three groups. If there are more than two groups, then you can't use the t-test. You can use the analysis of variance. So kindly take a look at this in preparation for Saturday, and please read through the explanation. And what's so special about ANOVA is that it will tell you if the means are equal. Okay, but since there are three groups, it will not tell you which of the means are not equal, are equal. So if you have, let's say, bad, good, and medium, and the result tells you that the means are not equal, using ANOVA here, the means of bad, good, and medium are not equal. The question is, which is not equal? Is it bad and good which are not equal, or is it good and medium, or is it bad and medium? The ANOVA will not teach us that. So therefore, you need what we call the post hoc test. Okay, I already also gave you the post hoc test. Okay, so please, so at least that's already up to code chunk here. Okay, and the interpretation is here. Right, so practical, I already gave you the answer and the codes to that. So may I, another post hoc test. Okay, so this one, okay, maybe we'll discuss this next meeting. Okay, so I'll not give this. So at least as up to two key post hoc test. Okay, all right, so let me stop recording.